Welcome back to Wickerson Studios. My name is Michael Wickerson, and I'm hard into the data science chapter of the one-liners for Python. And I think instead of going through tutorials on every one of these simple nodes, I may just cover it very generally, because now I'm realizing I really have to write the content of this text, or at least the ideas, the concepts hidden within it, into each of the nodes. So if you want to get a hold of this one will cover everything since the basic. Pretty much every function. It's running off of this whole chapter about data science is tied explicitly to the ghPython remote node and where to track your location and then bring in the modules you need. And actually, all of it to now has only needed NumPy, the library, to do things. So I've run through all these examples, made some videos. I'm going to pack all this last section into this short video, but really encourage people to jump on my Patreon if they could. Check out the GitHub site, grab yourself the user objects, and load them up and have fun with these. This is the first one that's basically dealing with slice indexing. Pretty simple stuff if you go back to what we were learning before, so I'm not going to go into too much detail there, but it's a lot of experimentation throughout the text. So I encourage you to read through these scripts, upload them, and you'll see that we try to adjust just some particular values in the example, and we just want to change specific values in the NumPy array with many rows. So here's one to begin with to keep it. Just get your mind back on slicing and indexing. So there's an array that's brought in. NumPy is going to translate it, and then here's the outcome of all of these print functions dealing with different slicing tools, reversing, start, stop, stepping, and possibly just start stopping, because it's the same as start, stop, stepping if you leave the last one just to negate it 1. Never make your steps at 0 because you'll get an error because you can't step by 0. So pretty simple stuff there. The NumPy concepts for multidimensional slicing is here, and you can see reading through that script pretty simply. I'll just set it up because it's all been, the comments have all been hard-coded in there to help you out, and I think that'll be fine. So think about that as once you've got your basic importing down and you know what's going on, you're understand multi-dimensional slicing. Apply one-dimensional slicing separately for each axis to select range of elements along the axis and try to fully understand this. So here's a multi-dimensional array, and then really getting into the slicing. This selects only the third column, and there's the output. This one selects the third row, 0, 1, 2. Remember, we start counting at 0. This script will print the second row every other element because you're jumping step every 2 on those, and it's the entire second row because 0, 1 is the count. Prints all columns except for the last one, and then this is the same. They suggest is working. The start, stop, step is the same as start, stop. So you can just go for the first row with this index going that way or that way. And I think it's no, it's not reversed. It's in order. Try some more and guess the outcome. Start, stop slicing is the same as stop, step slicing. If you understand the basic idea of multidimensional slicing is trivial. Very nice stuff in here. Here's the next one. Have a look at broadcasting, dealing with axis shapes, and then hopefully getting on to broadcasting, which I think we're just preparing for in the sense of understanding axes and shapes of arrays. So this one, import and do all this jazz. So put in that basic thing that I have up here in my sample file, and then we're looking at attributes of axes, shapes, and broadcasting. I don't think broadcasting yet. A is going to be equal to this array, and if you're going to use this dimension tool of ndim, that's the array attribute ndim, which stores the number of axes. And this is very limited to what it does, but it does work. And you're basically getting an output of 1, 2, 3 because those actually 1, 2, 2 is interesting. Why is that 1, 2, 2? Why is this not 3? Interesting. How did that one go back to 2-dimensional array? Oh, that is interesting because it's just one big list. I didn't do anything fancy here. Actually, let me check that out. I think I have to make a correction on that. And I think it's the brackets. I think it's the brackets separating. I don't think I wrote in the additional you're going to have to write in another split to split these two so they're separate lists, and this should solve the problem. If it doesn't, I'll hit stop, we'll figure it out, and I'll reload. But let's separate it like that. Let's do a check. And there we go. We got the three-dimensional array. I just didn't have those two separate. Now we can only see the dimension, the ndim of that, so that's not really helping us out too much. There's the test. So obviously this is why you like to watch the videos, because even when you get the files, there could be something funky and wrong in it. I'm not perfect. And then here's the one where you use tuple elements to, which defines the dimensionality. And this one's exciting because here's where you're going to get more data back out of it. You get this 3L. Now in the book, you don't get these L's. But I do get the L's in here. And I think that's interesting. We're going into what is import all that jazz. Hang on a second. Let's take a look at this last one. Here we go. Note, if you increase the dimensionality of the array, the new axis becomes 0, and the ith axis of the low dimensional array becomes the I+1 axis of the high dimensional array. So let's start with the first one, and if you're going to use the shape attribute, that's good because it actually prints you the shape of the function. There it is. And 1 is it's a tuple. It actually comes out as a tuple. So I should maybe make note of that, but it usually just says 3 comma, at least in the text. And the text wasn't written that long ago, so now very recently they have 3L, which the L must symbolize length or of it. I'm not sure. The next one, as we draw it together and use the shape tool, you can see you get a little more information out of it. You get this tuple instead of just the number count. And this is going to come in real handy for broadcasting, so we're going to get there. And you'll learn what broadcasting is, I think, by the end of this. And then the last one, because I have the right commas in here, which I had to fix in the last one, you can see that you get these double arrays printed for you, and you have a double, so it's 2 by 3 by 3. So each one's 3 by 3, 11, 12, 11, 22, 33 by 11, 44, 77. So you can go 3 and 3 in different directions, but you have actually 2, and that comma causes a little space to occur here, which is kind of nice, between the arrays packed within the arrays. So you're dealing with lists of lists of lists by that time. So hopefully this is starting to make sense. Let's come back out of it. Broadcasting is the act of converting a low-dimensional array into a higher-dimensional array to perform elemental-wise operations. So this is what we're going to get into, is how can we actually do that. Now I'm remembering grade 10 math. It's starting to come back to me, and I'll know how I can start to do the arithmetic and the adding and minusing and division to arrays, because we'll start making them to the right dimension between them. So let's just keep rolling. That's a simple, fast video. It'll link up with all those past, I think, 09, 010, 011, 012, and 013. And we're going to go on to homogeneous files at this one.